All right, so we are continuing with zeros, or going back to zeros. So we are going to talk about some very special kind of zeros, and we are going to talk about how to help some kind of strategies to help us kind of guess some zeros. So we're not going through, guessing everything. So we're going to start with what is the fundamental theorem of algebra. So this says that for every polynomial function of degree n with n greater than or equal to 1 has at least one zero in the system of complex numbers. So recall that real number is also a complex number. So kind of as a little reminder here about how your numbers work. So we have your rationals. So rationals are numbers that are like your integers, so whole numbers and their opposites, 0, and then a fraction of all those integers. Then you have your rational zeros, which is anything I can't really write as a fraction of integers. Those fall under what makes up, or they make up what we call the real numbers. The real numbers are part of what we call the complex numbers. So we had talked about this when we talked about complex numbers. So this is really telling me that there has to exist for a function of degree n, at least one zero in the complex numbers, meaning I just have to have a zero. It could be a real zero, it can be a complex zero. So the only difference we have here is that we have complex real zeros. So that could be like x is equal to -3 or 2 or 5, or it could be 2/5. All of those work because they're irrational. We could also have like 2 minus square root of 3. All of those, because this is rational, this is irrational, they're all real numbers, but they're all complex. We also can have complex non-real zeros, or non-real numbers. And those are the zeros that would look like 2 minus I, or 3 minus 6I, or it could just simply be 7I. So either what we're saying here is that I can have a zero of any of these forms, and that's perfectly fine. It's just that I have at least one. So for an example, we have a polynomial function of degree 4. So what this is telling me when I say it's degree 4, it's telling me that I should have 4 zeros. So we have, in fact, 4 zeros right here. We have 1, 2, 4i, and -4i. So we want to find a polynomial function. So what we're going to do is we're going to take those zeros and we're going to find the factor for it. So if I have a 0 of 1, that means I had to have a factor of x minus 1 to make that possible. If I had a 0 of 2, that means I had to have a factor of x minus 2 to make that one possible. If I had 4i, that means I had to have a factor of x minus 4i to make 4i a root, or a 0. And if I had -4i as a 0, that means I had a factor of x plus 4i. So we would have a polynomial. So we're going to put an a out front. We'll explain that a in a second. But essentially, it will look like this. Now, the reason we have this a is because this could be several numbers. Like this could be 3 times all these factors. It could be -7 times all these factors. But what's important here is that all those factors are going to give me roots. So what we have here is really like a family of polynomial functions that would have these particular zeros. And all we have to do is just change that coefficient out front. We're going to make life easier on ourselves. And we are going to make that just 1. So this will be my polynomial. So even though, like I said, this is just a polynomial, that will work for us. So there's this tendency that what we'd like to do is not present it in factored form. So we would actually have to expand this. So I'm going to pause this a second, and I'm going to get this ready so we can expand. Okay, so by expanding, what I'm going to do is I'm going to FOIL these and then FOIL these. So if I FOIL the first two, I'm going to have x squared minus 2x minus x plus 2. But FOIL over here, I'm going to get x squared plus 4ix minus 4ix minus 16i squared. We're just simplify this a little bit. So we have like terms here, so that's going to be x squared minus 3x plus 2. Here we simplify, we got x squared. These two cancel each other. And then this I squared is just a -1, so -1 times 16 plus 16. FOIL again, x squared times x squared is x to the 4th. X squared times 16 is 16x squared. -3 times x, -3x times x squared is -3x cubed. -3x times 16 is -48x. And then the 2's, 2 times x squared is going to be 2x squared, and 2 times 16 is 36. So we get x to the 4th plus, minus 3x cubed. Then my x squareds added together, it will be 18x squared. Then I only have the 1 with the x minus 48x plus 32. So like I said, there's multiple others I can have. If I like multiplied everything by 3 or 7 or something like that, that could be another polynomial. But yes, this is just one of the many polynomials that we could have of degree 4 that has the zeros 1, 2, 4i, and -4i. So take a minute on this one. So these are roots as well. So remember, we had these kind of roots when we did complex numbers and then quadratic formula. We'd have roots that had square roots in them. So this is a 5-degree polynomial. So you have 5 roots. So find their factors and then expand. So take a minute and work on that. Okay. So to get a root of -4 means we need to have a factor of x plus 4. To have a root of 3 means we have to have a factor of x minus 3. To have x as, or sorry, have 0 as a, well, 0, we need to have just x. Then if I want 1 plus the square root of 2, I would have x minus 1 plus the square root of 2. So we'll expand that negative out. And then if I want 1 minus the square root of 2, I would have x minus 1 minus the square root of 2. So don't forget the a out front. Like I said, we'll probably change that. So just to make it easier on ourselves, we're just going to say a is 1. So this x we usually write out front. We don't usually put it in the middle. So we put the x first. And then x plus 4, x minus 3. And if we FOIL this, this is x minus 1 minus square root of 2, x minus 1 plus square root of 2. Okay. Now to expand, we're going to do these in groupings like this again. We'll have that x, and this will end up being x squared minus 3x plus 4x minus 12. If we expand this part, we'll have x squared minus x square root of 2. Then we'll have minus x again plus 1 minus square root of 2. Now if we go with the -2 and expand that across, we're going to end up with negative, we'll do it like this, negative x square root of 2. Then we ended up with a positive square root of 2. And then negative square root of 2 times square root of 2 will just give us -2 because we got a square root times the square root disappears. So simplify. So notice that what happens here is because these are conjugates. Oops, that should be a plus there. Sorry, one was the wrong sign. Just let me see here for a second. So we had x times, yes, this is plus. Sorry about that. So this x times square root of 2 was a plus. This negative square root of 2 times x was a negative. So those two cancel out. These square roots cancel each other out. So you're left with x squared, negative x, and negative x, so negative 2x, and then 1 and -2, so -1. So now we'll just FOIL here. So x squared, x to the 4th, x squared, -2x, negative x cubed. X squared times the 1 is, I think that's clearly a 1, is a negative x squared. X times x squared is x cubed. X times -2x is -2x squared. X times -1 is -x. -12 times x squared is -12x squared. -12 times 2x is going to be is going to be plus 24x. I was trying to fix that. And -12 times the 1 is just going to be plus 12. So we got our x to the 4th. Now if we do our cubes, we got -2 plus 1. So that's going to be a negative x cubed. If I do my squares, I got -1, -2, -12, -15 x squared. Now if I do my x's, -1 plus 24, so plus 23x, and then we have plus the 12. So if I expand one more time, I have x to the 5th minus x to the 4th minus 15 x squared, or x cubed, plus 23 x squared plus 12x. So like I said, this is just one of the possible polynomials that is a 5-degree polynomial with these 5 roots.